Welcome to a RoboDemo case study carried out by the AIM Centre in Sligo, Ireland and funded by Interreg NPA. This case study evaluates the technical and operational feasibility of deploying a robot or cobot within a manufacturing company. This company specialises in producing rainwater management systems, fascia, soffit and cladding solutions. The company encountered challenges related to labour shortages and workplace safety. Employees were required to operate machinery independently in isolated areas of the factory, creating significant safety risks. In the event of an accident, there was no effective system in place for promptly alerting management or summoning assistance. Implementing an automated punching solution is an attractive option, not only to address labour challenges and boost overall production and turnover, but also to enhance workplace safety. The AIM team investigated the viability of automating various processes throughout the production facility and found the punching process was the most suitable application for robotic integration within the factory, as it is highly labour intensive and well suited to automation due to its repetitive and structured nature. The video illustrates the existing workflow where the bracket is initially cut and deposited into a container. This container is subsequently moved to the punching station where the brackets undergo the punching operation. The finished parts are then placed into a designated container via a chute. A range of design concepts were explored, and research was conducted into new technologies and systems to identify the most cost-effective solution. Various part feeding options were assessed to determine the most suitable approach for the application. The AIM team evaluated the current process and developed several improvement concepts. The images highlight the issue of material waste in the punching operation, with the image on the left illustrating one of the proposed solutions. Enhancements to the cutting process were assessed to minimize material waste and improve product quality. This included the integration of air blast systems to effectively remove residual debris from the saw area, therefore preventing dimensional inaccuracies in bracket widths caused by material buildup. Additionally, the implementation of automated material feeding systems was explored to facilitate continuous, unattended machine operation over extended periods, enhancing overall efficiency and reducing manual intervention. Given the average payload is under 500 grams, the robots and cobots listed above have more than sufficient capacity. However, the required reach exceeds 1.4 meters, making a robot more suitable than a cobot due to its lower overall cost. Additionally, since the saw and press machines will require guarding, it's more practical to enclose the entire setup with a robot. End-of-arm tooling options for the robot were evaluated to determine the most efficient and application-appropriate solution. Multiple design concepts were developed and evaluated, with the presented CAD model representing the proposed solution identified as the most cost-effective and operationally beneficial for the company. This video demonstrates the initial design concept developed by the AIM team. It features a parts feeder that supplies cut brackets to the robot for punching, allowing the saw to punch and operate independently. The operator only needs to refill the parts hopper every few hours. However, this approach is relatively complex and costly. This video demonstrates the proposed design concept, considered the most suitable for the company's needs. In this setup, the robot grips the part directly at the saw before it is released by the vise, ensuring consistent and accurate picking. The part is then transferred to the punching station for hole punching, followed by a vision inspection station. Once inspected, the finished part is placed on a chute and directed into a box. The solution is highly cost-effective, as the company already possesses most of the required equipment, except for the robot, guarding, and related components. The AIM team conducted a detailed cost analysis for the project, breaking it down to individual equipment expenses and calculating its return on investment. With support from the local enterprise office, the team also helped the company identify relevant grants available for this system. The long-term cost advantages of the proposed solution include substantial savings through automation, enabling extended operational hours for the punching process. Additionally, the system enhances product quality by optimizing the cutting operation and integrating a vision-based inspection station with the robotic cell. The proposed system also mitigates safety risks by enclosing both the punch and saw within the robotic cell, thereby eliminating operator exposure to pinch points, sharp objects, and other potential hazards. This design promotes a safer working environment and ensures compliance with relevant occupational health and safety standards. Thank you for taking the time to watch our Robo demo video.